ECE 302 paper. Today the topic is number system. So you already know a bit of number system techniques, the different classification of number systems, because nowadays in your 11, 12 you have included this topic in your syllabus. I assume that, but still I am recapitulating it. The different number systems, actually possible 4 number systems are decimal, binary, octal and hexadecimal. Basically they are classified depending on the radix value. Now radix is actually the base of the number system. If the base of the number system is 2, then it is binary. And we are just telling like 1, 2, 3, 4, 10. These numbers are actually decimal numbers. Okay. So decimal means the radix value is 10. So it is written here. See, decimal numbers, base is 10 and the possible numbers is 0 to 9. The range of the number is 0 to 9. Binary numbers, base is 2. The possible values are 0 and 1. Next is octal numbers. Octal means base is obviously 8 and the range is 0 to 7. And hexadecimal numbers, it is having the base 16 and the range is actually from 0 to 15. But in case of digital, we call it as binary coded decimal. So 0 to 9 is valid number, and from 10 to 15 we say it like A, B, C, D, E and F. That is why the range is written like this. It is 0 to 9 and A to F. Okay, if the 16 is base, then the possible numbers are 0 to 15. As we are starting from 0, so the last value will be 15. So it is not 16, it is 0 to 15, and for 0 to 15, 0 to 9 is the range and the other numbers are known as A, B, C, D, E, F. So 10 will be A, 11 will be B and so on. 15 will be F from this. Now we have different conversion techniques for all these number systems. So we can convert any decimal number to binary as well as octal as well as hexadecimal and so on. So again the vice versa is also possible. Binary numbers can be converted into decimal as well as octal, hexadecimal and so on. Okay. So one by one I will explain these conversion techniques. First I am starting with, see, you have to identify what is the range, what is the base value written here. This is 10. So this is one decimal number and we are converting it into binary number. Why? Because here the radix is written as 2. Okay. So you can expect these kind of questions in your semester as well. Okay. These kind of problems will be coming in your upcoming semester. So this is the 243. It is in decimal and we have to find out the corresponding binary number. What is the procedure? As we have to find the binary number, we have to divide the number with 2. Okay? So we are dividing it 2 and we are getting the remainder. It is the remainder actually. So the answer is coming like 2 1s are 2, 2 2s are 4, 2 1s are 2. So 242, 243 minus 242 is 1. So the value is coming here 1. I hope it is visible properly. Next is we are dividing this 121 part again with 2. Okay, and we are getting 120. So again 1 is remaining and we are writing it here. Next, going forward, we are dividing it with 2. 30. 30 into 2 is 60. So remainder is 0. Okay. Next, 2, 15 2s are 30, remainder is 0. 2, 7 2s are 14, and now we are getting left with 1. Next, 2 3s are 6, and we are getting it here 1. 2 1s are 2, and the remainder value is 1. Now, you should always remember that the answer should be in reverse order. So, if we are starting from here and ending at here, then it will be a wrong answer. Okay, so you have to maintain the reverse order for writing the answer, starting with this one. So the answer will be 1 1 1 1 0 0 1 1. See? So 243 corresponding binary value is 11110011. It is in binary. Okay? Pretty much clear, I think. So moving forward to the next problem. So first we have to identify it is given in decimal and we have to express it in the octal. That is why the base is 8. So we have to divide it with 8. So in case of binary, we were dividing with 2. So now we have to divide it with 8. And if you divide it, then the remainder is actually 3. And after that, 3 is divided with this 8. 8 3s are 24. So remainder is 6. Okay? Now again we have to write in the same manner, that is in the reverse way. So starting with 3, 6, 3 in octal. So the conversion is coming as 363 in octal. Next, hexadecimal. Next problem is the same number I am showing and the same number I am taking in this decimal and converting into the different other number system technique. Okay, this is the 16. So hexadecimal. So we have to divide it with 16 and we are coming as 53. Okay, because 15 cannot be divided again with 16. So 15 and here we are coming as we are getting that 3. So 15 and 3. Now 15 is not a valid number in hexadecimal. 15 we have to write it as if. I have already told you that. That is why the answer is if 3. Clear? Okay. Next, I will show you the other techniques as well. Find out it is the number in binary system and we have to convert it into the decimal. So what is the procedure? Whenever the conversion is in decimal, we have to follow this procedure. Okay. So base is 2. That is why I am writing 2 to the power. Now how we are giving this weightage? Starting with this value, the LSB. It is known as it is known as LSB, least significant bit, and this one is the MSB, most significant bit. So the LSB is 1 here, the weightage is 2 to the power 0. Why? Because base is 2. So 2 to the power 0 into 1 plus 2 to the power 1 into 1 plus 2 to the power 2 into 0 plus 2 to the power 3 into 1 plus 2 to the power 4 into 0, 2 to the power 5 into 1, 2 to the power 6 into 1, 2 to the power 7 into 1. So it is 1 7-bit number. Okay, this is actually 8. 1, 2, 3, 4, 5, 6, 7, 8. 8-bit number. But as we are starting from 0, here we have to weight it like 0, 1, 2, 3 and so on. So the answer coming like 2 to the power 0 is 1. And any number to the power 0 is 1. 1 into 1 is 1. 2 to the power 1 is 2. So 2. 2 to the power 3 means 8. But 2 to the power 2 is 4. But 4 into 0 is 0. Okay? 2 to the power 3 into 1, that means 8. 2 to the power 4 into 0, so 0. Anything into 0 is 0. 2 to the power 5 into 1, it is 32. Next, 2 to the power 6 into 1, it is 64. 2 to the power 7 into 1, it is 128. And we have to add them. The number is, the addition is coming as 235. And this is the answer. Now, if we have any values like point something, what to do? Point something. Then the procedure is, point is one reference. Okay. You can imagine it like a mirror. So mirror, from this reference, we are giving like 2 to the power 0, 1, 2, 3, 4 and so on. And from this point, we have to put the weight as 2 to the power minus 1, minus 2, minus 3 and so on. Okay. 0 is covered here. So we have to start with 2 to the power minus 1, 2 to the power minus 2 and if it is given like in point, that means the problem is 1110, 1011, 0.011, suppose. Then, next, this is 247 in octal. So, 247 in octal, that means in base is 8 and corresponding decimal number we have to find out. So, we are just writing 8 to the power 0 as it is 8. So 8 to the power 0, 8 to the power 1, 8 to the power 2. Because it is 1 3-bit. See? 1, 2, 3 only. And multiplying it with the number 7, 4 and 2. And you can multiply it and you will get the answer like 167 in decimal. Okay. Just like that, whenever it is in hexadecimal, then the corresponding decimal number. Whenever the conversion is from any number system to decimal, this is the procedure. So 16 is there, so 16 to the power 0, 16 to the power 1, 16 to the power 2 and 16 to the power 3. Okay. And this 8EB4. So 8 is 8, but E is actually 14. B is 11 and 4 is 4. And we are multiplying it, we are getting the number like 36532 in decimal. Okay. So this is the technique for this portion. Is the technique for converting any number to corresponding decimal number. So up to this I am covering in this video, and in my next video I will start with this binary to octal and binary to hexadecimal conversion. Thank you.